Hi, Mr. Green here. I'm going to take you through the next section of the forces topic of the AQA Physics GCSE. We'll focus today on momentum, and you'll learn an objective to describe and calculate the momentum of an object. Pause the video whilst you take that as your title. Okay. Retrieval questions to start with, so if you pause the video whilst you attempt these 5 questions and restart it when you'd like the answers. Okay, question 1. What's meant by stopping distance? Stopping distance is the distance a car travels between a hazard appearing and the car coming to a full stop. So when the driver sees the hazard, puts his foot on the brake, and then comes to a full stop, that's the stopping distance. What 3 things can affect thinking distance? Distractions in the car, loud music or people talking behind you, the consumption of alcohol or drugs before driving, and being tired before you drive the car. 3 things that can affect braking distance: condition of the road, if the road's icy or slippy or the weather's bad, the condition of the tyres, if they are worn or if they've been used too much, and the condition of the brakes. Question 4. What's the unit of acceleration? That is meters per second squared. And question 5. What 2 factors affect the amount of kinetic energy an object has? That would be the mass and the velocity. Okay, our learning outcomes today are to know what's meant by momentum and to calculate momentum. Okay, I've got 2 bowling balls here. Which one's easier to stop? The bowling ball moving at 5 meters per second or the one moving at 50 meters per second? Pause the video and write your answer. Explain to me why you think that one would be the easiest one to stop. Okay, so the first bowling ball, the bowling ball moving at 5 meters per second, would be the easiest to stop. Now, both bowling balls have got the same mass, but the velocity of the second bowling ball is a lot higher. We'd say the second bowling ball has got more momentum. Okay, so it's the first time we're using this word momentum. We can see both balls have the same mass, but because that has the higher velocity, it's got more momentum. Okay, so we've got another 2 objects here, a bowling ball moving at 10 meters per second and a tennis ball moving at 10 meters per second. Which one of those 2 would be easiest to stop? Pause the video whilst you write your answer. Okay, the tennis ball would be easiest to stop. And this is because both balls have got the same velocity, but the mass of the bowling ball is higher. We would say the bowling ball has got more momentum. So, with those 2 in mind, what 2 things affect the momentum of an object? Mass and velocity affect the momentum of an object. Momentum is the product of the mass and velocity of a moving object, and the way we calculate momentum is to use this equation. Momentum equals mass times velocity. We need to be careful here because we need to ensure we get our units right. Mass is in kilograms, velocity is in meters per second, so momentum is in kilogram meters per second. Write that down and ensure you commit that to knowledge. Momentum is measured in kilogram meters per second. As far as the symbols go, we would call that P equals mv. So a quick example, a car's got a mass of 800 kilograms and is travelling at a velocity of 40 meters per second. What's its momentum? Momentum is mass times velocity, so that's 800 times 40, giving us 32,000 kilogram meters per second. A bullet's got a velocity of 200 meters per second and a momentum of 10 kilogram meters per second. What's its mass? So in this case, we have to rearrange the equation. Momentum is mass times velocity. Rearrange that to make mass the subject, so that's momentum over velocity. Mass is 10 divided by 200, momentum is 10, velocity was 200 meters per second, giving us a mass of 0.05 kilograms. And a pram has got a mass of 80 kilograms and a momentum of 400 kilogram meters per second. What's its velocity? Again, we'd need to rearrange our equation to make velocity the subject. So rearrange the equation. Velocity is momentum divided by mass. That's 400 divided by 80, 5 meters per second. So we need to rearrange the equation if we want to find velocity or mass. But momentum, we just multiply the mass and velocity together. Okay, with that in mind, there's 4 questions for you to do there. Please pause the video and attempt those questions. Okay, question 1. Answer would be 750 kilogram meters per second. Number 2, 850 kilogram meters per second. Number 3, 4.8 kilogram meters per second. And number 4, 30,000 kilogram meters per second. Try these 4. You'll have to rearrange the equation for these 4, so pause the video and attempt them. Okay, number 1, 12 meters per second. Number 2, 7.05 meters per second. Number 3, 8.63 meters per second. And number 4, the lorry's got a massive 857 kilograms. Now, momentum is calculated using mass and velocity. Velocity being a vector quantity means it's got size and direction. So when calculating momentum, we've got to consider direction. If direction changes, velocity changes. So if direction changes, momentum changes. When we calculate momentum, we need to assign the direction to it. So for the following questions, we're going to assign positive as moving to the right and negative as moving to the left. So if the value we calculate has a positive value, it's moving to the right. If it has a negative value, it's moving to the left. So let's look at an example with that in mind. 2 cars, both with a mass of 900 kilograms, are moving in opposite directions. Car 1's got a velocity of 15 meters per second to the right, and car 2 has a velocity of 18 meters per second to the left. Calculate the momentum of each car. So for car 1, momentum is mass times velocity, so that's 900 times 15. I've kept 15 as a positive because it's moving to the right. If it's moving to the right, that's positive in our directions. Giving us momentum of 13,500 kilogram meters per second, and as it's moving to the right, it's got a positive momentum. Now, because values are already positive, we don't need to add that positive sign to the answer. If there's no sign in front of it, we assume it's positive already. Car 2, it's got a momentum of 900 times 18, giving us momentum of minus 16,200 kilogram meters per second. As it moves to the left, it's got a negative momentum. So we show this by adding a minus sign to the start of the number. So we know it's moving to the left, so we'd assign that as a negative. With that in mind, could you answer those 3 questions for me, please? Pause the video and off you go. Okay, so question 1. Momentum of a vehicle that's got a mass of 30 and moves 10 meters per second to the left. Momentum would be 30 times minus 10. Momentum is minus 30 kilogram meters per second, minus because it's moving to the left. The vehicle's got a momentum of 6 kilogram meters per second and a mass of 5 kilograms. What's its velocity and what direction is it? It's momentum divided by mass for velocity. Velocity is 6 divided by 5, giving us 1.2 meters per second. That's a positive value, so it's moving to the right. If 2 vehicles collide, they stick together after the collision. One vehicle's got a mass of 100 kilograms, the other a mass of 50. Final momentum is minus 200. So what's the final velocity? So we rearrange the equation. Velocity is momentum over mass. Velocity would be minus 200, that's our momentum, divided by 150, that's the mass of each vehicle that's joined together, giving us minus 1.3 meters per second, and that movement would be to the left as the figure is negative. Okay, I hope that was useful for you. Please subscribe to our YouTube channel and look at any of the other videos you'd need to try and revise for your topics. Thanks for your time. Speak to you soon. Goodbye.